Yesterday, there's really two parts to lesson 6.2. And the first part, what we did yesterday, was just being able to find the inverse of a relation and the inverse of a function. So having that understanding of what an inverse is, what the inverse means. And then the second part of the lesson that we didn't get to was being able to determine if two functions that are given to you, if they are inverses. And so I'm going to show you the relationship two functions have if they're inverses. So and this is going to be a good review before your homework quiz of one thing that could possibly be on there with composition of functions. So you can determine if two functions are inverses by finding both of their compositions. So that would be f of g of x and then g of f of x that we talked about a couple lessons ago. And then if both compositions equal the identity function, which is just x, so f of x equals x, then the functions are inverse functions. So what this box here explains in words, two functions f and g are inverse functions if and only if both of their compositions are the identity function. In symbols, what that means, I'm just going to look at the second part. So f and g are inverses if and only if f of g of x equals x and g of f of x equals x. And they both do have to equal x. So if you remember when we were finding compositions of functions, f and g, or f of g and g of f, are most of the time not equal to the same thing. If two functions are inverses, though, they will equal x. They will both equal x. So you do have to find both. And then just remember the alternate way to write both of these. So the first one is f of g. You could write it this way. That's, again, typically how I write it. And then g of f, you could write this way. I think that more easily shows which function is being substituted into the other. So that's what we're going to be looking at. There's two different pairs of functions given under example 3. So part A is on this page. We're going to go through both together. And then, like I said, I'll have you do the two problems that were on your assignment that you didn't have to do last night. So it says determine if they're inverse functions and then explain your reasoning. So we have f of x is 3x minus 3. G of x is 1/3 x plus 4. So to determine if they're inverses, you want to start by finding one of these two compositions. And it doesn't matter which one. I usually just start out by finding f of g of x. So just find one of the two compositions first. And so this, like I said, is going to be a review of how to do that. So f of g of x means I'm substituting g into f. So I'm going to replace the g of x here with the 1/3 x plus 4. So I'm finding f of 1/3 x plus 4. So then this shows in the function f, I'm replacing the x with 1/3 x plus 4. Everything else stays the same. So I have 3 times the quantity 1/3 x plus 4, and then minus 3. And then I want to simplify this. So to do that, I would need to distribute 3 to the 1/3 x plus 4. And 3 times 1/3, they would cancel each other out. That would just be x. Plus 3 times 4 is 12. And then I still have the minus 3 at the end. And 12 minus 3 is 9. So this is x plus 9. And for this problem, then, I can stop here. Because in order for these two functions to be inverses, both compositions have to equal x. So I don't even need to find g of f because f of g of x is already not equal to x. It's equal to x plus 9. So I would say f of x and g of x are not inverses because f of g of x does not equal x. And I've showed in my work what it does equal so that it's clear it doesn't just equal x. So if two functions are truly inverses, you should see that when you substitute one function into the other, all of the operations cancel out so that you're just left with x, and that clearly didn't happen with the two functions we had. Okay, so if in your first composition, whichever one you try to find first, if it doesn't equal x, you're done. If it does say to explain whether or not they're inverses, though, make sure that you're including the y. Okay, questions on A. Okay, so then for B, B's on the back page, same directions. Two different functions, f of x is 2x squared minus 1, g of x is the square root of x plus 1 over 2. So again, I want to figure out if they're inverses. I can start out by finding f of g of x. And I'm just going to replace what g of x is. So I'm finding f of g of x is the square root of x plus 1 all over 2. And then that means in the function f of x, where I see the x, I'm replacing it with that square root. So I have 2 times, in place of x, the square root of x plus 1 all over 2 squared, and then minus 1. And then you simplify. So if I start with that exponent, what happens when you square a square root? Cancels out. So then I have 2 times the quantity, so the square root's now gone, so it's just x plus 1 all over 2, and then minus 1. And then when I multiply this fraction by 2, what happens? The x plus 1 stays. So be careful, this is what catches, or what in the past has caught some students. This 2 is like 2 over 1. So some students want to distribute the 2, which you could. But what they do is they distribute it to the x plus 1 and they distribute it to the 2, and that's what's incorrect. If you're distributing the 2, then the bottom gets multiplied by 1 and just stays 2. An easier thing to do, though, is to realize that these 2's cancel each other out. They're just gone. So then you just have x plus 1, and you don't need the parentheses anymore since nothing is being multiplied by it, and then minus 1, and the positive and negative 1 cancel, and you just have x. Okay, so that's what you want to see happen, or rather what you will see happen if two functions are inverses. However, you're not done. So we know f of g of x equals x. You also then have to show or see if the other composition also equals x. So you also then have to find g of f of x. So in this case, I'm going to replace the f of x with 2x squared minus 1. So I'm finding g of 2x squared minus 1. So that means in the function g, that x gets replaced with the quantity 2x squared minus 1. So I have the square root of 2x squared minus 1 plus 1 all over 2. And I know I put parentheses around the 2x squared minus 1 just to show I'm replacing the x with it. The parentheses aren't really necessary, though, because 1 is just being added to it. So in this case, that minus 1 and plus 1 would cancel each other out. So then I would have the square root of 2x squared over 2. And then 2 over 2 cancels out. So I have the square root of x squared. And we just said before, a square root and a power of 2 or a squared cancel out, and that's just x. Okay, so then we can determine that these two functions are inverses because both compositions equal x. So I would say f of x and g of x are inverses because f of g of x equals x and g of f of x equals x. So really, no matter what the two functions are, if they're inverses, your reasoning would be the same for every single one. But the reasoning is what shows me that you understand why they're either inverses or they're not. So if this type of question was asked on a quiz, I would ask you to explain why or why not are the two functions inverses. I just want to make sure that you understand if you're saying yes or no, why you're saying yes or no. So then, like I said, from here, the assignment you had yesterday, whether or not you did the rest of it, I'd like you just to have that out and then look at numbers 8 and 9. And I know it says determine whether each pair of functions are inverse functions, right? Yes or no. And you can write yes or no, but if you want to just practice writing out the reasoning as to why you're saying yes or why you're saying no, most importantly, I want to see though that you can determine if they're inverse functions. So I'll give you a chance to do those. I'll walk around. I can check what you have, answer questions that you have before we move forward. All right, I'm going to show this. I know if you're not quite done, I think other than maybe at the beginning, for the most part, once I got to the other side, at least you were done with 8. So in terms of what I would be looking for if this type of question was asked on a summative quiz or test, I would want to see your work for what you're trying to find. So even just having the reasoning, if you have no work to back up, say why this is not equal to x, you're not going to get full credit for that. Or if you're saying, yes, they're both equal to x, but you didn't actually show they were, I need to see that you're actually finding them correctly. So I would need to see that you're finding those compositions, or at least finding one to show that they're not inverses, and then your reasoning. So that's more or less what I'd be looking for. I know on your assignments right now, some of you understand why or why not, and you're just kind of saying no or yes, that's fine. Just so you know what I would be looking for. So are there questions on this? Okay. Then